Hello, everybody. In this video, we want to talk about a new type of function called a logarithmic function. And this logarithmic function is motivated by the idea of an inverse. So earlier, we had shown that um, this exponential function is a one-to-one function. And based on the previous section's material, we know that when a function is one-to-one, it has an inverse. So the natural question to ask is, how do we find this inverse? And if you follow the steps for how we want to find an inverse, the first thing you usually do is you usually introduce this variable y. So you got y is equal to b to the x, right? And then the next thing that you do is you interchange the x and y. So you got x is equal to b to the y. And then the last step would be you want to solve for y. The problem is our variable is in the exponent, and we have no way of bringing this exponent downstairs. So what we do is we actually cheat a little bit. We create a whole new notation, and this whole new notation means the solution to this equation. Okay, so we define the logarithmic function to be as follows. We write the logarithmic function like this, but what's its meaning? Its meaning is it's the solution to this equation right here. So um, this equation on the left is called the logarithmic form. And this equation on the right is called the exponential form. And this statement, if and only if, means this is called a bi-directional implication. So what it means is that if someone writes y is equal to log base b of x, they mean that this is b to the y equal to x. So this equation means this is true. Bidirectional means the opposite direction is also true. So if I go in the other direction, if we say, oh, when this equation is true, that means that this is also true. So we are basically going to be switching between exponential and logarithmic forms. Okay. So of course, we have the usual caveats that the base has to be bigger than 0 and the base is not equal to 1. This is true for any exponential function. All right. So the way that you want to think about logarithms is logarithms are really exponents. So we're really asking ourselves, to what power must the base b be to be raised to obtain x? So maybe I'll show you a simple example um, off to the side over here. So let's say that I have something like y is equal to log base 2 of 8. Okay. So, usually I want my examples to be in blue. So let me change this to blue. Okay. So this is the logarithmic form. So what does that mean? Well, the first thing you want to do is you want to write the base. So the base is 2. The logarithm itself is always a power. So we're going to put the y in the power. And this whole thing is equal to 8. Okay. And then the natural question is like, what would y have to be in order to make this equation true? So the easiest way to do this is to rewrite 8 as a power of 2. And as you may know, 2 times 2 times 2 is 8. So then this would be 2y is equal to 2 cubed. The last thing we can say is that we can say, since we know that the exponential function is 1-to-1, if the exponential function has the same output, that means the two inputs have to be the same. So this means that y has to be equal to 3. So in the end, what have we done? We've said, oh, if I want to figure out what power of 2 I need to raise, what power do I need to raise 2 by in order to obtain 8? The answer to that question is 3. Okay. All right, folks. We will talk more soon.